All right, so let's go ahead and review what we discussed on Monday. So that scenario, I'm just going to pull it down here real quick, involved me swimming for 40 minutes, which is laughable, but this is a fictitious scenario. So I'm swimming for 40 minutes. The intensity is easy. Intensity was consistent the whole time, and more importantly, it felt easy the whole time. So the way that you should be interpreting this is no fatigues occurring. So in that scenario, and also the scenario I'm presenting today, no fatigue. I will add in an extra layer of complexity for fatigue next week in those scenarios, but we're not doing that yet. So I'm just setting the foundation for how you should read this now, and this means no fatigue. I haven't voluntarily changed intensity either. It was easy to start, and it stays easy the whole time. Lastly, I remain cool, meaning my body temperature is within a normal range, and I'm well hydrated. I would say I'm not sweating much, but it's hard to tell because I'm swimming, right? So it's well hydrated, okay? And based on this, sort of a quick review, at onset, which again, that will always be defined as the first few seconds of activity, okay? We had to describe 3 things about our neuromuscular recruitment. One was that there was a few motor units recruited, and not just any few, the type 1s. And that goes along with what you've learned already for neuromuscular recruitment and the size principle and all that fun stuff. And what I want us to agree on is that when you see this clue, easy, this is how you would describe the motor unit recruitment, right? And maybe you use something else like few or some or a little, or something that indicates not very many motor units are being recruited, okay? And along with that cue of easy, decided that slow rate coding would be an appropriate way to describe the speed of action potentials. On the metabolic side, remember that at onset, because it's just the first few seconds, there isn't really time to significantly ramp up glycolysis or mitochondrial respiration in like a meaningful way. So that means the immediate system is our dominant system, which basically means that our dominant fuel is ATP and creatine phosphate. Because this is our dominant system, there's triggers for enhanced glycolytic activity. That's something you should recall from metabolism. And specifically, what enhanced glycolytic activity refers to is increasing, emphasis on the ing, like present tense, glycogenolysis and glycolysis. So here we're breaking apart the glycogen to free up some G6P that we can then run through that glycolysis right there. And then there's not a lot of time, again, these first few seconds, to take a bunch of extra breaths or to significantly ramp up heart rate to supply oxygen for mitochondrial respiration. So in order for mitochondrial respiration to be increasing, we need to use stored oxygen on our myoglobin, right? And the early Christmas present, so to speak, is that these 4 things that you would use to describe metabolism at onset, these don't vary based on the scenario. So any scenario I'll throw at you, these are always your 4 options. Always. No context, no nothing. These are your 4. So definitely memorize those and then just always use them if that makes sense. On the CV side and the respiratory side, remember that there's an exercise pressor reflex in these first few seconds, which means as soon as you move, your brain registers that muscle activity and it automatically ramps up sympathetic output. So largely what we see here is a reflection of that increased sympathetic output. So on the CV side, we've got increasing heart rate, stroke volume, ejection fraction, cardiac output, rate pressure product. These are all our heart-based parameters. And then on the blood pressure side, we see systolic and blood pressure and mean arterial pressure increase. Diastolic pressure is unchanged. And the reason it's unchanged is because this is an aerobic activity. So that's the context you need to be clued into, right? Remember that SVR, systemic vascular resistance, is going up initially, and that's because we haven't had the time yet for local vasodilation to occur that would really open up the channels for blood. So because there's just sympathetic output and things are starting to vasoconstrict, we see that go up, and of course there's that vasoconstriction reflected there. And on the respiratory side, everything is increasing, but we would describe the ventilation as being proportionate. It's a proportionate increase. It's linear because it's easy. And again, the context that I would usually add in here is well below lactate threshold. So that way, if easy wasn't enough of a trigger for you to say, gosh, should it be proportionate, disproportionate? This should be a redundant trigger. So you're like, oh yeah, the lactate threshold thing, got it. Okay. So once we get into our exercise session, in the example I gave y'all, it was during 30 minutes. So I wrote that incorrectly. I was writing that for today's example. Let me change that real quick. So for the swimming, 30 minutes in, remember, it had remained easy. I hadn't changed my pace at all. I wasn't experiencing fatigue. So that means that this description right here for neuromuscular recruitment was applicable for easy there, and it's still applicable here. So nothing changes. It's the same as onset. Okay. However, we are 30 minutes in now, so the dominant system would be mitochondrial respiration. And we talked about how when you're well below lactate threshold, when it's easy, typically lipids are the dominant fuel source there. That'll change with some of our other scenarios to come. And even though lipids are the dominant fuel source, that doesn't mean you're not using carbohydrate metabolism. So to try and reflect that point, we talked about elevated but stable glycogenesis and glycogenolysis. Remember, glycogenesis means you're making glycogen, and glycogenolysis means you're tearing it apart. And that was sort of a new point, right? That during exercise, you can be making glycogen just so you can tear it apart. And the benefit of that is you're always getting G6P for any glycolysis that would occur. And because we're under lactate threshold, we are producing lactate and protons. You're always producing some. You're producing some right now, even at rest. But it's not very much, so we're able to easily shuttle that out of the muscles so there's no accumulation in the muscles that would create some fatigue. That's going to change when we start talking about fatigue. On the cardiovascular side, a lot of those things that were increasing have now stabilized, so we would describe that as elevated but stable. Heart rate, stroke volume, ejection fraction, cardiac output, rate pressure product, SBP, MAP, systemic vasoconstriction, all those are basically trimmed out. Diastolic blood pressure remains unchanged, but now we've got these EDRFs eliciting a local vasodilation, and as a result of that, SVR actually drops. And not only does it drop compared to onset, it actually drops compared to rest usually. So we would describe that as decreased but stable, right? And again, you can go back to that shorthand or terms video to see a visual trend that this term would correspond to. On the ventilation side, we don't have to describe ventilation as increasing proportionately or disproportionately anymore because it's now stable. It's elevated but stable, as is everything else. So it's sort of just trimmed out, which is a good thing. Yeah, Dawson.
So reason these parameters are elevated but stable due to the fact that the intensity is consistent the whole time?
That's exactly right. The intensity is consistent and there's no fatigue, right? So if there was a fatigue element, which we'll get into, we'll see that these things aren't going to be stable. Yeah, but right now, the exercise intensity is consistent and there's no fatigue. Yep, great clarification. Now on the post-exercise side, there's nothing to describe neuromuscularly because you just beached on the side of the pool, right? Like a starfish, right? You're not recruiting anything, so there's nothing to describe there. To try and describe epoch that would occur after that exercise session, we would say that mitochondrial respiration is decreased compared to exercise but increased compared to rest. I wanted to point out something new as it related to carbohydrate metabolism, and that was that there was this 20 to 30 minute window post-exercise where you can get a jump on your carbohydrate replenishment. And what that means is that there's increasing gluconeogenesis, this is the formation of new glucose, and increasing glycogenesis, the formation of new glycogen, right? So if you do a workout, consume carbohydrates within 20 to 30 minutes. That's not the only time you can replenish carbs, but it's definitely a really optimal time to try and do that because these things are increasing compared to normal. And then any lactate and protons that were in the muscle during exercise, those are now shuttled out of the muscle after exercise. On the CV and respiratory side, basically anything that was increased during exercise has to come back down, right? You don't finish a workout and then your heart rate stays the same, right? Indefinitely, it's going to come back down. But it's not going to come all the way back down to resting levels because of this epoch thing. So the term that we would use is decrease compared to exercise, increase compared to rest, and that applies to anything that was elevated before. And that also applies to our respiratory stuff too. Remember, diastolic blood pressure was unchanged the whole time, so it's still unchanged. And with SVR, it was decreased but stable, which means it's going to start coming back up towards rest. So we flip our arrows, right? It's increased compared to exercise, but now decreased compared to rest, just a smidge. Does that help? We'll review. Any questions on this before we start in with our next scenario then? Maddie.
On the quiz, like just trying to study for this, I know it's just going to be repetition, but like, so you would ask like during metabolism within the 30-minute mark, what's increasing or what's decreasing?
Typically, I word it very ambiguously. So I would say, I would usually give some context and say, okay, we're now 30 minutes in. As it relates to the neuromuscular system, describe 3 acute responses, right? And basically, this is 1, 2, 3, right? And this is actually a really good point. I was going to make this later today, so I'm glad you're asking it now. If we're looking at metabolism, 1, 2, 3, 4, right? When we're looking on the cardiovascular side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So each of those counts as their own response. This large line is not one response. That makes sense? So usually the way I'll grade this out is it would be a point for, say, elevated but stable heart rate, right? A point for elevated but stable stroke volume. If you just put heart rate, then you're going to get -half, because I don't know if it's going up or going down or whatever. So let's just say, for instance, that you list all these out, but you have the wrong term here. It's -half, 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 right? So definitely make sure that you've got the directional terms correct. Now, if you want to spend a lot of time typing, you can do a term for every parameter, but it's probably more efficient to just list it once and then put everything behind it that's applicable to that, right? But you got to make sure if you do that, that you know that the term that you're providing is right so that you don't lose a lot of points. Does that help? Yeah. Other questions? Okay. Well, let's go ahead and start in with today's scenario. So I'm going to pull this down real quick. Amber is up to bat. She is the focus of our scenario today. Thank you, Amber. And what she is doing is she is performing traditional resistance training. Remember that the picture I've painted for this thus far is you do a set and then you take a rest. You do a set and then you take a rest. It's very intermittent in nature. And I'm starting with traditional resistance training because it fits with what we've learned thus far about cardiovascular responses and respiratory responses. I will give you a scenario next week where we start to blur the lines between aerobic and resistance exercise by doing circuit training, okay? And you're going to be able to see how the responses reflect that blurring of lines. But for now, let's keep things as far apart as possible, right? This is a very different type of exercise than this right here. Now, she is doing this traditional resistance training for about 30 minutes. Note that the intensity is now higher than it was over there. It's now moderate, but Moderate, I'm defining still as at or below lactate threshold. Okay, so I'm going to provide that context so that you know how to answer ventilation. Is it increasing proportionately or disproportionately? Same as the other scenario, her intensity is fairly consistent the whole time, meaning that she's not experiencing fatigue. She didn't start with lighter weights and then start upping the intensity throughout the workout. She's sticking with basically the same loads the entire time, right? Really easy workout. And, well, it's a moderate workout, but it's a simple workout. That's what I meant to say. Like the other scenario, she remains cool, so her body temperature is not increasing. She's consuming a lot of fluids, so she's well hydrated. And now that we're not talking about someone that's in a pool, it's easy to see that she's not sweating much, okay? And so, again, this set of clues is laying a foundation for a layer of complexity we'll speak to in our next scenario on Monday, and that's something called CV drift, right? So all you need to know right now is when it's cool, well hydrated, not sweating, that means no CV drift, which you have no idea what that is yet, but you will once we get to that, right? So this is still a pretty different or a simple scenario, but what's different from before is the mode of exercise and the intensity. So based on those two small variable switches, what I want you to see is how would we change the responses from that first scenario, okay? Let's start with our neuromuscular system at onset, okay? So the neuromuscular system, when we were at an easy intensity, I said you were recruiting a few or some type 1 motor units now. Well, let's come up with some agreed upon language that would reflect a moderate intensity. So moderate intensity means that there's a greater force output, so you know you've got to be recruiting more motor units. And per the size principle, as you add more motor units, you'll eventually start bumping up into larger motor units. So let's just say that moderate intensity corresponds with the recruitment of all type 1 motor units. And let's just say it's a few or some type 2A motor units. So all type 1, a few or some type 2A motor units, and those are recruited. Okay. And if the intensity has increased from easy to moderate, that means rate coding has sped up. What might be a good term we could use for a slightly faster rate coding? What do you think? Anyone? Just come up with a word. I want something that's different than slow to reflect that this is sped up, right? How about moderate, right? It's a moderate intensity. Let's go with a moderate rate coding. So now what I've got here is a reflection of this increased intensity compared to that first scenario. Yeah, Kenzie.
On the quiz, can you say like RC, or do you have to say rate code?
Yeah, I would let you say RC. Yeah, at this point I'm assuming you know what that is. Yeah. Good question too. Cool? Remember that at onset, we always have the same 4 metabolic points. There's nothing that needs to be changed here, right? So we still have an immediate system that's dominant, which means we're relying on these fuel sources. There's enhanced glycolytic activity, which I want you to specify the actual things. If you just said enhanced glycolytic activity, you won't get full credit for that. I am looking for both of these, okay? And we're still using that stored oxygen and myoglobin for increased mitochondrial respiration. On the CV side, remember that when it was an aerobic scenario, that's a different mode of exercise than resistance training, almost everything was increasing except diastolic blood pressure. What happens to diastolic blood pressure during resistance training? What have you learned? Dawson's doing this. Yep, that's exactly right. So how we change our scenario here is we just add diastolic blood pressure into that list. Everything's increasing. On the respiratory side, everything would normally increase: ventilation, frequency, tidal volume, bronchodilation. But we have to describe if ventilation is increasing proportionately or disproportionately. And based on my revised graphic, if it's at or below lactate threshold, we would describe it as proportionate. It says up there we are at or below lactate threshold, so I'm going to keep that as proportionate. So as it relates to onset, from scenario 1 to scenario 2, you can see I've changed very little. And the two things that I needed to help me know what to change and how to change it was the mode of exercise. We're now doing resistance training, and that meant that my diastolic blood pressure is now going up. And the intensity, we're now moderate, which means I had to describe my neuromuscular recruitment differently. Does that make sense? Any questions on that so far? Liz?
So, for recruitment,
Mm-hmm.
you have 4 answers in one?
No, I would actually call this, so I would still count this as 3, because basically these tell me how much, and these tell me what type. Yeah. Good question, thank you. Other questions? Let's move to during exercise. So in this scenario, Amber is busy getting yoked, doing her traditional resistance training. And let's just say that we catch up with her about 25 minutes into this 30-minute session. Now remember, her intensity has been consistent the whole time, meaning that she hasn't been trying to increase the loads that she's using, and she's not feeling fatigue, right? So our neuromuscular recruitment is the same as onset, right? This should still reflect a moderate intensity, and if this is how you're describing moderate, then that's how you describe it there. Now typically, it's worth mentioning on a quiz or an exam, there's a little bit of fudge room on some of these, just a little bit, right? So if you were answering responses for during, I'm usually going to look at how those compare to onset. So that if you happen to use slightly different lingo here than I've got on the board, but it seems plausible, then I would basically be looking to say, okay, is this the same in this scenario? Or let's just say she had increased her intensity. I would want to see that whatever you've used here reflects an increase from whatever you've listed there. Does that make sense? So to try and make it simple, what I'm doing with the scenarios is I'll basically give you easy, moderate, hard intensities, and I'm going to give you some language that corresponds with each of those. So at that point, it becomes more of a memorization thing. But know that there is a little bit of fudge room there, so that if you kind of have a mental pause and you're like, I don't remember, and you just do your best, know that I do give credit for some answers that are a little bit different than what I've listed, so long as it makes sense within reason. Okay. All right, so back to our during though. Amber hasn't changed her intensity, it's still same as onset. We are doing traditional resistance training here. So that is going to change some of this stuff. With aerobic exercise, with our first scenario, no doubt that mitochondrial respiration was the dominant system. This is a bit of a tricky one because with traditional resistance training, you've got the exercise portion and then you've got the resting portion. Which one do you focus on, right? What I think I would like to focus on is just a simple recommendation is let's try to answer these questions based on the exercise portion of the scenario. So in this case, how would we describe the dominant system during her sets? Okay? And in this case, with resistance training, it's always going to be well, not always, but generally speaking, it's the immediate system. Right? With traditional resistance training, it will always be the immediate system is the dominant. That's what I intended to say. And as we learned already with onset, whenever the immediate system is dominant, what does that make our dominant fuel? ATP and creatine phosphate. Now it's worth mentioning that even though the immediate system is dominant and the dominant fuel is ATP and creatine phosphate, there is still carbohydrate metabolism occurring, just like with the previous scenario. And because everything is consistent, we would indicate it's elevated but stable. Same terms again, glycogenesis and glycogenolysis. And because our intensity is moderate, we're at or below lactate threshold, that means that we're going to take lactate and hydrogen ions and we're going to shuttle those out as quickly as they're made. So my during responses for metabolism have changed very little, and what prompted me to change this, in this case, was the mode. Does that make sense? All right, on our CV side, remember that with the first scenario was aerobic, so that meant that there was a lot of cardiovascular parameters that were elevated but stable, diastolic was unchanged, and SVR went down, right? What you've learned thus far with resistance training is that everything goes up. So how I would change this is I would take the diastolic blood pressure and the SVR, and I would just add them to this list right here. And I would say that those are elevated but stable, and keep that simple. There's definitely still EDRF release, but remember that even though there's EDRF release, which causes local vasodilation, SVR is going to go up with resistance training, because if the focal point is what's happening during the exercise, during the set, we've got so much muscular compression of vessels that blood pressures go up, which means SVR goes up. So, like up here, it was the mode in our scenario that prompted the change down here. Okay? So these reflect resistance training, whereas what was before reflected aerobic training. Okay. Maddie?
So then if we were to change that to focusing on the rest portion, then we'd have the glycolytic system and all that.
Yeah, but I won't. Yeah, and hopefully that's not even in your head, right? Just look, we're always going to try to focus this on what's happening during the exercise piece, which makes sense because it's exercise physiology. Yeah. Hopefully that'll be a good trigger. Okay. And during aerobic exercise, all the respiratory things were elevated but stable. Guess what? They're still elevated but stable. What you learned before was that aerobic would elevate these things more than resistance, but you did learn that all of these things went up with resistance training. So this still tracks with what you know. Okay? So no change there. Post-exercise, Amber is now laying on the ground, reveling, basking in her success for finishing this workout. So there's nothing to describe there. She's got EPOC going, so we still list that. Maybe she's eating a peanut butter sandwich because she's trying to get the benefit of this enhanced carbohydrate metabolism, and any lactate and protons that she made shuttling out of the muscle. So look at that. Nothing's changed compared to that last scenario. It's worth mentioning, on the onset side, we've got our 4 things to describe here. These are never going to change for any scenario. I've mentioned that already, right? These 3 things that you see for metabolism post-exercise, never going to change. Every scenario, always the same. So that keeps it simple. Okay. CV side, remember, because it's resistance training, everything went up here, which means now everything needs to be in this list as well. Everything's going back down compared to exercise, but it's slightly elevated compared to rest. So I take this, I delete it, and I just add it in to this list right here. And since the respiratory stuff, it all went up, it's all coming down. So, taken as a whole, I used a different color here to try and illustrate just how little has changed in the way you would describe the acute responses for a scenario that's different than what we've learned already. And the two differences, yet again, I know I'm sounding like a broken record, but I want to just drill it in. We have a different mode of exercise, and the intensity is now higher. And I have changed things based on that intensity or mode. As it relates to the neuromuscular recruitment, this now reflects a higher intensity. On the CV side, this now reflects a different mode of exercise. And on the metabolism during side, that now reflects a different mode of exercise. And I think that's about it. Oh, word of warning, caution. As you're studying this, the one thing that I have seen frequently as an error is people will jumble up stuff. They'll put CV stuff down here or respiratory stuff up there. Or if you look at all this carbohydrate, I mean, there's a good. I mean, there's a lot of syllables, a lot of G's. It's really easy to mix those up. So I would just be extra mindful of trying to remember which ones belong in which categories. So, cool? All right, that's all I got for you. Thank you so much for being here. I appreciate it, gang. See you later.